The topic today is going to be SolidWorks drawings. So if you open up SolidWorks, you guys will remember that we had ventured into assemblies for the first time last time. That was the first time that we had clicked off of the part file. Now we get to click into the drawing file. Again, if you get to this by going up into File New, you'll see there's this big button called Drawing. That's what we want to do. The drawing part file within SolidWorks creates a drawing, just like we talked about way back in week 1. A mechanical drawing wherein you have two-dimensional representations of your part or your assembly, on which you typically supply enough information to actually make the thing. So if I click Drawing and click OK, just like with the assembly file, first thing it's going to do is prompt me for something to insert. That is, of course, after it asks me what type of page I would like to use. By default, you have a nice little setup with some default drawing templates, all of which are terrible. If you click on, for example, A3, that's going to be like the closest that we can come up with to a reasonable size document to look at here. If I click OK, it's going to create a new drawing of that file size. And then it's going to prompt me to insert a part or an assembly. So I can go back up to the same interface like we had back in assemblies and click on a part. So since I happened to be looking at the piston parts last week, we can just jump right back into that. If I click on the piston itself here and click Open, just like with the assembly, the first click I do after that places the file. By default, the SolidWorks drawing is going to be generating a model view wherein I have a front perspective, and then if I click a second time, I can place another projection. So in this case, either right or top or left or bottom, or an isometric view from the top right, or an isometric view from the top left, or an isometric view from the bottom left, or an isometric view from the bottom right. All of them are at my disposal here. So if I drag to the right and click, and drag up and click, and maybe drag up and right, I can create the typical 4-view projection of a standard SolidWorks part. These drawings are all linked together, just like they would be if you were actually drawing this by hand. You want to make sure that your right view lines up vertically with your front view, and that your top view lines up horizontally with your front view. The isometric view can pretty much float around wherever you like. Also, like assemblies, any modification that you make to this part will propagate the next time you open the drawing. So if you change some dimension, you don't have to worry about the drawing needing to be manually updated. It just grabs all the geometry from the SolidWorks part or assembly. So we've created a view of a part. Again, if you missed that, what I did was I went into a SolidWorks drawing and I went up and inserted a part using a model view and clicked on piston, clicked once to define my initial base view, and then from that, my subsequent clicks define additional projections. So in some cases, you might only need 2 views. In some cases, you might need 3. Personally, I like the front view, the side view, the top view, and the isometric view. These are the views that you should be used to from doing the homework assignments. You can also change things like the scale within this interface on the left. You can change what style is used to render the drawing. For example, if I want it to show hidden lines, I can click this Hidden Lines Visible button. It'll show me all the hidden lines. If I want it to be shaded, I can click the Shaded button, and it will appear as it did in the 3D viewer within the SolidWorks part. Make sense so far? Be aware that your additional projections are tied back to your base view. So if I change the way that my base view is rendered, like for example, if I show hidden lines, that propagates on the top view and the side view. If I change the scale, if I were to say make it a 1:2 scale or a 1:5 scale, it changes all of the other projections because they are tied directly to the base view. From this, I can create some sort of dimensioning by using the same sort of tools that we had when we were creating sketches. So I can go back into the sketch interface. I can create dimensions off of this. For example, if I wanted to add a diameter to my drawing, I can add a diameter. I could add heights of stuff. I could add widths. I could add other diameters. It's all the same set of tools that you used when you were creating sketches. Generally speaking, it doesn't take much time for people to figure out how drawings work. Do you have any questions initially? Okay. You'll also notice that in the bottom right-hand corner of your drawing, you have a whole bunch of information that isn't relevant to this class. So the logic here is your drawing for an actual company needs to show enough information to tie to whatever you're contracted for. You may tie it to an order, you may tie it to an assembly, you may tie it to a customer. You typically have signatures of everyone who was involved in the design process, the engineer who designed it, the person who drafted it. Any modifications that you make to the part, you would create a new revision, you would initial that, hey, I created a new revision, and you would date it. All of that information is in this little block. Depending on the environment, you might have additional requirements like what type of finish is necessary, what type of material is necessary, any special notes about how the thing needs to be built or put together, all of which are on this tiny little block, none of which are relevant to this class. It doesn't make a whole lot of sense for us to spend much time on the default SolidWorks templates because no one actually uses the default SolidWorks templates. Any company that you work for that uses SolidWorks is going to have its own templates for this sort of thing. They probably would have the company logo on it and whatever information is relevant to that industry. So we aren't going to spend any time at all on the default SolidWorks templates. Instead, we're going to be using our own ME212 template, which requires that we install the ME212 template into SolidWorks. To do that, first step is going to be to go into D2L and download the template files. So under D2L, if you go up to Content, you'll notice you have a new folder over here on the left called SolidWorks Template Files. That contains the two files relevant to our template. It contains a set of instructions in case you have trouble following along with this video. And it also contains 3 examples of the sort of dimensioning that you are expected to provide on an ME212 drawing submitted for grading for the homework assignment as well as for the SolidWorks project. So what we need to do is download these 2 files, ME212, the drawing dot file, and the landscape ME212 file. And then we need to install those by placing them into the template directory. The template directory is located here. See program data, SolidWorks 2018 in my case, because I'm running SolidWorks 2018, templates. For your installation, it might be in a slightly different location. You might have it in a SolidWorks 2017 folder. You might have it in a different user folder, depending on if you installed this on Macintosh, simulating what Windows looks like, or if you actually install it on a native Windows platform. In the event that you are curious about where your document template folder is, you go up to Tools, Options, and then from the left you select File Locations. This will walk you through where the important files are located for SolidWorks. By default, it should populate with document templates because it knows that's most likely what you want to change. If you were curious about where other things were located, other template files for different types of installations that you're trying to run, you can change those by jumping into these folders. What I want is document templates. So we could add our own special document templates folder, and we could put that in some special ME212 folder, but it makes just as much sense for us to dump these ME212 files into the default location. So take note of this. See Program Data, SolidWorks 2018 templates. We need to navigate to there. To do that, I'm going to open up a file explorer. I'm going to find those 2 files. I'm going to copy them, and now I'm going to navigate to this location. That's C. Program data. You'll notice program data doesn't appear under the C drive. That's because it's a hidden folder. You can get there by either enabling viewing hidden folders, which I can do by going up into folder options, show hidden files, folders, and drives, or you can also just type C:/program data. Then, come on SolidWorks, show me, there we go. C program data, SolidWorks 2018, templates. We have made it to the directory. Hooray for us. Now I can paste in my 2 new files. This computer already has them installed, but I'll overwrite them for funsies. You should now have 2 additional files located in your C program data SolidWorks 2018 templates folder. At this point, I can close File Explorer, and I can exit out of SolidWorks entirely and restart it. Now, when it loads this time, it's going to go grab those new template files, and we have the ability to create a new ME212 drawing. To do that, we are going to click on this Advanced button in the bottom left. Congratulations. We are no longer novices. We are advanced. So under Advanced, you have ME212 as an option for a new file. Anyone get lost on any step in that process? Okay. So going through that entire process again, we go into D2L, we download 2 files from content, SolidWorks template files. We download ME212, that's a DRW-DOT file, and then a landscape ME212, that's an SLD-TRT file. Those are the 2 relevant files to creating this new template. Then we find where those were placed and we put them into a special folder. In the event that you don't know where that special folder is on your computer, you can go into SolidWorks, Tools, Options, File Locations, Document Templates, and you can read off this location. C, Program Data, SolidWorks 2018 Templates. Now I navigate to there. To do that, I'm going to open up File Explorer on my Windows computer. I'm going to go into C drive. I can either enable hidden files and folders, or I can just type into the bar at the top C:/Program Data. Once I am in the Program Data directory, it's just a matter of navigating the rest of the way. SolidWorks 2018 Templates. Then I paste those 2 files into this directory. You could also, I suppose, if you wanted to, just type into the bar at the top all the way from the beginning, C:/Program Data, SolidWorks 2018. No, SolidWorks 2018 Templates. That would also get you there. Whatever the case, you need to paste those 2 files into this folder and then restart SolidWorks. Once you have restarted SolidWorks, you now have the ability to create advanced parts. So you can get there by clicking on the Advanced button in that wizard that pops up when you open SolidWorks, or by going up into File, New, Advanced from the bottom left-hand corner, and then clicking on ME212. Everyone right there with me? So we need to get files from our Downloads folder to that special SolidWorks folder. So you could move them if you wanted to. You could copy and paste. Again, that's C, Program Data, SolidWorks 2018 Templates on my computer. And we need to get them from here to here. We could move them by highlighting them and clicking and dragging. We could right-click copy and then right-click paste. We could move them with a special command if we wanted to. Oh, I don't have privileges to do that. That's cool. Not cool, man. You could also download directly into that folder if you wanted to. Yes?
Should the document template in SolidWorks correspond with what year of SolidWorks that you're using?
It will correspond with what year of SolidWorks you installed. So by default, SolidWorks will create a document templates folder, and then it'll use that every time you update. So,
yeah, so it says 2017, but you're using the 2019 version.
That is A-OK. What's important is that the file location that appears under File Locations, yes. And if you really want to, if you're really struggling with it, you can just create your own templates folder and then add it to this list. That's also fine. Other questions? Okay. When you have put those files into that folder, you need to restart SolidWorks and then create a new file from the Advanced section. So we can get there by clicking on the Advanced button from the wizard that pops up when you open SolidWorks. You can also get there by going up to File, New, and then clicking on Advanced in the bottom left. So when you click on ME212 and click OK, we have a much simpler legend in the bottom right. It has information that's relevant to you submitting homework for this class. It's also an 8.5 by 11 sheet of paper. The scaling should make more sense for what we're actually doing. So now, within this interface, we can actually create drawings for the parts that we want to. For example, if we wanted to create a new drawing for, I don't know, what was something that we made last time? Oh, I've got it, weird hat assembly. If we wanted to create a drawing for the hat, we could just select hat, click open, and then remember, the first time you click initializes a base view. Every subsequent click creates an additional projection. So I might want a right view, I might want a top view, I might want an isometric view. To get those, I click to the right, I click to the top, and I click to the upper right. But of course, the world is your oyster. If you don't want a right view, you could always create a left view by dragging off to the left and then clicking. You could create a bottom view by dragging down and clicking. You could create an isometric view from the bottom right. You could create an isometric view from the bottom left. You could create an isometric view from the top left. You have many options. And by many, I do of course mean you have 8 options. When you're done creating additional projections, you can hit escape or you can click the green check mark. At this point, you would move your part around until it actually made sense on your drawing. You would add some dimensions by going up to Sketch, Smart Dimension, and then applying dimensions. You'll notice that the ME212 drawing template uses inches and will by default show 2 decimal places and inches after your dimensions. If you want to change that, you can click on the dimension, you can change the number of decimal places to use. In some cases, it might make more sense to use 3 or 4. For example, if you're trying to indicate 1/8 of an inch, if you have 0.125, that makes more sense than 0.13 inches. Additionally, you'll notice in the bottom right-hand corner, your title of your part automatically populates to whatever was your file name for the part. You'll notice you have ME212 Mechanical Engineering Design Technologies appearing underneath the file name. You'll also notice that your name says student name. When you submit homework assignments in the form of drawings, what I want you to do is update student name to contain your actual name. To do that, you first double-click on it. This gets you into editing the block. Then you click an additional time onto student name. And now you can type your name. When you are complete, you can hit enter or the green check mark. And now you have an ME212 drawing. Any questions? Yes?
Why'd you choose that name of all of them?
Well, I have Game of Thrones on the brain, and I thought Joffrey would be plagiarism. So I, of course, invented a new person who is completely unrelated to Joffrey. It would be Jeffrey Baratheon, the much overlooked cousin. Do you have any additional questions? When you are complete with an ME212 drawing, you can save it. You will save it as a Solidworks drawing file, and I also ask that you create PDFs. To do that, you go up to File, Save As, and Save As type PDF. For each of your drawing homework assignments, you will submit a drawing file and a PDF. Your drawing files should have enough information that someone could recreate the part from your drawing. So you're going to be applying dimensions, and you're going to be applying enough dimensions to fully define the part. Most students have a default inclination to try to over-define everything, applying dimensions everywhere. Remember, you only need enough dimensions to fully define the part. You don't need to have every dimension listed everywhere because you don't want to create conflicts in your tolerancing. No, that's okay. Do you have any other questions?
Is the PDF just the same thing, just more simplified?
Correct. The PDF is just so that,
It doesn't change.
right. The logic here is as follows. If you open up the SolidWorks drawing file it will open up the SolidWorks part or assembly for which you created the drawing and then generate the drawing. So we still have your SolidWorks parts from your homework submissions, but if we open up the drawing file and it doesn't appear in the right location, we have to go find it. So the PDF is an easy way to see it. Other questions? Okay.
Does it like say when a part is fully defined in there?
Nope. You have to think through how many dimensions you actually need. And I will point out that your homework assignment for this week is to create drawings for all of those, not all of them, but some of the files that you've created in previous homework assignments. So I asked that you go back and create a drawing from the donut, a drawing from the rook, a drawing from the bishop, and a drawing from the fuselage from homeworks 2, 3, and 4 respectively. So if you're creating enough dimensions to model it, you're probably going to create a drawing that looks pretty similar to the drawing that appeared on the original homework assignment. So if you still have that, you can just open it up and try to recreate it. I also asked that you create a drawing from one of your other choose your own adventure parts. You can do whichever one you like. Other questions? Okay, with that, we conclude SolidWorks as a topic for ME212. Again, the goal wasn't necessarily to make you experts at everything within SolidWorks. The goal was just to get you up to a base level of fundamentals so that you can figure out the other stuff that you need to know for special circumstances in future classes. Hopefully you found it somewhat interesting. Hopefully you enjoy playing with SolidWorks. It is fun to create 3D models of stuff. Instead of a midterm for SolidWorks, I asked that you create a SolidWorks project. So again, within the context of grading in this class, 10% of your overall grade is dedicated to SolidWorks homework assignments, of which there are 5. 20% of your grade is dedicated to MATLAB, of which there are question mark. You have 5% of your overall grade to Excel, which is what we're going to be doing in my part of the class after we finish SolidWorks. You have 5% to your lab grade. And then your midterm is broken up into a midterm exam. That's going to be over MATLAB. That'll be on Thursday. And a SolidWorks project. So I don't think SolidWorks works very well as a traditional exam format. So instead of an exam, your midterm grade for SolidWorks is a project. Your project is assigned today and is due in a little bit over 3 weeks. Under SolidWorks project, under the Dropbox, you can see my list of requirements. Your goal is as follows. I want you to create a compressor. That's pretty much all the specifications that I give you. So my logic here is I want you to have the freedom and flexibility to create something that you find interesting and to be as detailed about it as you want. The very first time we did this, I let people make anything. I said you can model whatever you like as long as it has at least 5 parts. And we got some very interesting creations. And also, like, a third of the class submitted just stuff that they downloaded off the internet. So that was complicated because that paperwork is a nightmare. But what I'm going for here is a little bit more control over it so that hopefully you create something within a certain scope. I will also point out that there are much fewer compressor models on the internet. While we're on that subject, by the way, if you aren't familiar, I would recommend familiarizing yourself with GrabCAD. GrabCAD is a resource that was originally created for common hardware. So the logic was basically like, instead of every engineer on the planet modeling their own M4 bolt every time they needed an M4 bolt, if there was like a common repository of SolidWorks parts that were commonly used by everyone, then that saves you the headache of creating a model for something and you can spend more time on whatever it is you're designing. It has since been kind of co-opted by educational resources, so some teachers have required that students submit projects onto GrabCAD, etc. But the cool thing about this is that if you were to type in anine, that's fun. That's obviously what I wanted. If you search for something, you can pull up a model of it in different types of 3D modeling software. If I narrow my software down to SolidWorks, then everything that I see here is a SolidWorks file. I think that there's a lot to be learned from downloading these and then opening them up and reverse engineering how they were created. I think it's interesting and certainly educational to see what other people have done. This is essentially the Chegg of SolidWorks, if you like. Were you going to ask a question?
I was going to say, is it like Revit City?
Okay, fair. It's very similar. So if I wanted to download like a compressor model, I could find all sorts of compressor models here. And while we're on that subject, don't do that. Don't submit stuff that you find on the internet. You will, at the very least, fail the class. It is outside of our hands now, by the way. The whole like school's intellectual property and academic honesty policy has changed. It used to be that the teacher had control over what happened to the student. Now it is decided by people above us, so that there's like a unified record among the Board of Regents of like what happened to different students. And generally speaking, the consequences are extremely harsh. So just don't do it. If you're going to make a model and you don't want to spend a lot of time on it, then make a bad model. It's better to have a bad grade on the homework assignment than it is to have no grade on the homework assignment. Anyway, within Solidworks project, I asked that you create a compressor. It can be whatever type of compressor you want. If you want a reciprocal compressor, if you want an air compressor, if you want the compressor stage of a gas turbine engine, all of them are fine as long as it meets the requirement of being a compressor. Yes, Liam?
Are we allowed to just look up dimensions?
Totally. Yeah, if you want to look up schematics of existing compressors and recreate that, that's totally fine, as long as you made the file yourself. I'm not expecting you guys to do the engineering to design a compressor from scratch. I want you to recreate something. While I'm on that topic, I will also point out it does not need to be a good compressor. Like, you don't need to accurately model every aspect of it. I don't need it to be functional. Within the context of the hypothetical situation for this project, you are creating a model of a compressor that is educational. It's a little over 3.5 weeks. So the logic here is that if you were actually 3D printing this thing, you could use it to show to students how a compressor works. So like, for example, if you create an axial compressor for a gas turbine engine, the reality of those rotors and stators is very precise geometry that has special types of curves in a lot of dimensions. If you wanted to make a model of it and you just make rectangles that represent the blades, that's totally fine. Does that make sense? All I ask is that it have at least 5 unique parts, and that you submit at least one assembly, at least 5 parts, drawings for at least 5 parts and your assembly, and images for at least your 5 parts and your assembly. In addition to that, I ask that you type a 250-word essay. This is not a writing assignment. You don't need it to be good. It doesn't need to have a thesis statement. I don't need it to cite references. I don't need it to follow a certain formatting scheme. Just 250 words vomited into a Word document and submitted is fine. My goal with that essay is for you to create something that explains to me your reasoning. You, the student, are explaining to me why you made what you made and how you went about doing it. So if you wanted to go create the compressor stage of a Briggs & Stratton motor, that's fine. You can go and look it up and tell me where you looked it up and how you approach modeling it. That is just fine. If you create 5 very simple parts and a simple assembly and it meets all my requirements, you will get a C at least. Going above and beyond, creating more accurate parts, creating more than 5 parts, creating more than 5 drawings for your 5 parts, that is what distinguishes a C from a B from an A. Does that make sense? So this is due at midnight of November 1st. So if you look at the calendar here, you have 3.5 weeks to do it. I'm not actually expecting that you spend 3.5 weeks on this. What I'm expecting is that you should make it when you have time. Like, we are right in the season where you guys probably have your first exam in a lot of your classes. I want you to have the flexibility to work on it when you have time to work on it, and to work on it enough that you can submit something that you're proud of, not just something that meets base requirements because you're desperately trying to finish before you take your Physics 211 exam or whatever. Does that make sense? Okay. So your submission for the Solidworks project, which is due midnight on Friday, November 1st, should have at least 5 parts, at least 1 assembly, at least images of 5 parts, an image of your assembly, drawings for your 5 parts, a drawing for your assembly, and then a 250-word essay. that means you're submitting at least 19 files. And I would ask that if you know how, if you could put them into a zip file and submit the single zip file, that makes my grading process faster. If you don't know what that means, don't worry about it. Any other questions? Well, okie doke. We have about 18 minutes left of class. I'm going to turn it over to my colleague. I will end the live stream